Hello, and welcome back. In the last video, we introduced the Internet of Things and its potential for increasing efficiency, innovation, and progress in our society. Today, we will discuss the components required to take the current successes of IoT in large-scale settings and bring them to smaller, more common devices that are present in our everyday lives. Cost, size, and compatibility must be considered when bringing IoT from industrial uses to everyday devices. IoT is already well developed within agriculture, construction, and large industry. This is because a high profit margin can be maintained with large equipment. The added costs of the IoT device to the overall production cost is minimal. Therefore, it does not have a dramatic effect on the consumer's price, especially when the consumer considers their cost-to-benefit ratio. Since a high profit margin must be maintained within all production settings, it is important to keep raw material costs low to avoid consumer prices from skyrocketing when IoT is introduced to new devices. Another constraint IoT must overcome as it transitions into smaller devices is its physical size and mass. If a computer will need to be attached to every watch, key fob, and/or thermostat, the excess space required will quickly make the benefits of IoT no longer worthwhile. Not only must the devices be small, but they must also be energy efficient, ensuring that the smaller batteries will last an extended period of time. As IoT expands into any and all devices, from big to small and stationary to mobile, it must be in a universal language so that it can communicate well with others. There are a number of means of communication, including wires, Bluetooth, and Wi-Fi, to name a few. The devices must also be able to communicate using a shared protocol in order to effectively relay a signal from one object to another.
One device that works particularly well for exploring the Internet of Things is a Raspberry Pi. A Raspberry Pi is a single-board computer that is roughly the size of a credit card and can be purchased for about $35. This computer, though small and inexpensive, is actually quite powerful. The Raspberry Pi is capable of running several different Linux operating systems. It can also use multiple coding languages, including Python, Java, or C. Additionally, it can send and receive signals using either Bluetooth or Wi-Fi. The Raspberry Pi also has many options available for attaching additional devices. The input-output pins are easily accessible for convenient attachment of various sensors and motors. Like many computers, a usable interface can be provided via a monitor connected using an HDMI cord. 4 USB 2 ports allow for a variety of possibilities, including the attachment of a keyboard and a mouse. The Raspberry Pi 3 is capable of wireless communication via Wi-Fi or Bluetooth, but an Ethernet cable can also be used. Using the card reader on the underside of the board, a micro SD card will provide the operating system and any necessary files. Another helpful and affordable device is an Arduino Uno, which is different from the Raspberry Pi in that an Arduino is not a full computer, as it does not have an operating system of its own. It is a microcontroller, a small device capable of running specific code that has been programmed onto it without an operating system of its own. Like the Raspberry Pi, it has input-output pins to allow for the use of various motors and sensors. Unlike the Pi, it does not have nearly as many ports, but simply one to allow it to attach to a computer using an AB USB cable. An Arduino Uno is smaller in size than the Raspberry Pi and is available at a lower price, costing about $20. Both of these devices are highly effective for use within the Internet of Things due to their small size, affordable price, and versatility for use with many different sensors. Despite their small size, these are powerful devices that can work together to send a signal to the cloud. For example, a person could attach a sensor, such as a motion detector, to an Arduino Uno or Raspberry Pi, using wires and the input-output pins available. That device would then send the data received from the sensor to a gateway, either a Raspberry Pi or Wi-Fi router, via Bluetooth. Once received by the gateway, a device more powerful and sophisticated than the Arduino, that information could then be pushed to the cloud, using Wi-Fi to reach a much larger IoT server to be processed, and if needed, a return signal could be sent to an actuator, such as a speaker. These devices work well together and are a great educational tool for those new to the Internet of Things.